Welcome to CH225 course on Statistical Data Analysis for Chemists. I am your instructor, Anil Kumar. These are my contact details. This is video 7 in this series. In this video we will learn about graphing distribution. Tabular and graphical representation of the data is the first and often most important step in data analysis. The numerical findings of a study should be presented clearly, concisely, and in such a manner that an observer can quickly obtain a feel for the essential characteristics of the data. Over the years, it has been found that tables and graphs are particularly useful ways of presenting data. These help in revealing important features, such as the range, the degree of concentration, and the symmetry of the data. Let us now look into a real example of how to present data from a given study. This study was carried out by Apple Computers when they introduced the iMac computer in August 1998. The company wanted to learn whether the iMac was expanding Apple's market share. Was the iMac just attracting previous Macintosh owners? Or was it purchased by newcomers to the computer market? Or by previous Windows users who were switching over? To find out, 500 iMac customers were interviewed. Each customer was categorized as a previous Macintosh owner, a previous Windows owner, or a new computer purchaser. Here is a frequency table for the results of the iMac study. It shows the frequencies of the various response categories. It also shows the relative frequencies, which are the proportion of responses in each category. For example, the relative frequency for none is 85 divided by 500, which is equal to 0.17. It is important to note that the total of frequency column should be equal to the total number of customers surveyed. The total of the relative frequency column should add up to 1 if the data is calculated properly. A quick look at this frequency table gives us a good overview of the data. It clearly shows that maximum number of iMac users were the previous Macintosh users. However, there were 12% of the customers who moved from Windows. There were 17% new users also. Therefore, it clearly indicates that the market share of Macintosh is increasing, wherein new users are joining, as well as Windows users are switching to Macintosh. This is the power of representing data in tabular form. We now look into representing the same iMac study data into various graphical forms. The first chart is the pie chart, as shown here. In a pie chart, each category is represented by a slice of the pie. The area of the slice is proportional to the percentage of responses in the category. This is simply the relative frequency multiplied by 100. Although most iMac purchasers were Macintosh owners, Apple was encouraged by the 12% of purchasers who were former Windows users, and by the 17% of purchasers who were buying a computer for the first time. Pie charts are effective for displaying the relative frequencies of a small number of categories. They are not recommended, however, when you have a large number of categories. Pie charts can also be confusing when they are used to compare the outcomes of two different surveys or experiments. Here is another important point about pie charts. If they are based on a small number of observations, it can be misleading to label the pie slices with percentages. For example, if just 5 people had been interviewed by Apple Computers and 3 were former Windows users, it would be misleading to display a pie chart with the Windows slice showing 60%. With so few people interviewed, such a large percentage of Windows users might easily have occurred, since chance can cause large errors with small samples. In this case, it is better to alert the user of the pie chart to the actual numbers involved. The slices should therefore be labeled with the actual frequencies observed, instead of with percentages. Another way to represent this data is using bar charts. Bar charts can be used to represent frequencies of different categories. A bar chart of the iMac purchases is shown here. Frequencies are shown on the y-axis, and the type of computer previously owned is shown on the x-axis. Typically, the y-axis shows the number of observations in each category, rather than the percentage of observations, as is typical in pie charts. Often we need to compare the results of different surveys, or of different conditions within the same overall survey. In this case, we are comparing the distributions of responses between the surveys or conditions. Bar charts are often excellent for illustrating differences between two distributions, as shown here. It shows the number of people playing card games at the Yahoo website on a Sunday and on a Wednesday in the spring of 2001. We see that there were more players, overall, on Wednesday compared to Sunday. The number of people playing Pinochle was nonetheless the same on these 2 days. In contrast, there were about twice as many people playing Hearts on Wednesday as on Sunday. Facts like these emerge clearly from a well-designed bar chart. A line graph is essentially a bar graph, with the tops of the bars represented by points joined by lines. The actual bar is removed. We note that it is a serious mistake to use a line graph when the x-axis contains merely qualitative variables. This figure inappropriately shows a line graph of the card game data from Yahoo. The drawback is that it gives the false impression that the games are naturally ordered in a numerical way, when, in fact, they are ordered alphabetically. Let us now summarize what we have learned in this video. Pie charts and bar charts can both be effective methods of portraying qualitative data. Care should be taken to choose if we use frequency or relative frequency in case of pie charts. Frequency should be used when data size is small. Bar charts are better when there are more than just a few categories, and for comparing two or more distributions. Be careful to avoid creating misleading graphs.